Today we are going to study about escape speed. It means that how much speed it should be given to a mass. Suppose there is a mass on the surface of Earth and we give it some speed such that it goes out of the gravitational pull of Earth. It goes to a very far away distance so that it no longer is in the gravitational field of Earth. So that will mean the escape speed. So escape speed means speed required to escape from Earth's gravitational pull or force. Okay, so we need to find out what is the speed. Usually when we throw something, it will come back. But now we want that when we throw this object, it doesn't come back and it leaves the surface of the Earth. So now let's try to find out and calculate the speed. Now suppose that there is on the surface of Earth there is a mass and it has some velocity. You give it some velocity and let that velocity be the initial velocity. And let us say that it goes to a very far away distance. And this distance is such that the velocity here is 0. And it is a very far away point. And now this distance from the surface of Earth to the center of Earth is the radius of Earth. And the distance of this point from the center of Earth is r maximum. And the distance between the point and the surface of Earth is h. So now if you have to find out, so let us say that this point has some kinetic energy and some potential energy. And this point also has some kinetic energy and some potential energy. Let us say this is initial and this is final. So initially it has a kinetic energy which is Ki, which will be 1 upon 2 mvi squared. This is because this mass is moving and this is at rest. So the initial kinetic energy will be 1 upon 2 mvi squared and the initial potential energy will be minus g mass of Earth, mass of the small object upon r. R is the distance between the mass and the center of the Earth. So let us say initially that because it is at a distance re, so we say the distance between the two masses is re, so initial potential energy will be this. While in the final situation, kinetic energy will be 0 because the final velocity is 0, while the potential energy will be minus g mass of Earth, mass of the object divided by the distance between them. Now the distance between them is r maximum. Now we have to understand that r maximum would be h plus radius of Earth. So now if we use energy conservation, then the total initial energy will be equal to the total final energy. So initial means initial kinetic energy plus initial potential energy will be equal to final kinetic energy plus final potential energy. So initial kinetic energy will be 1 upon 2 mvi squared, and potential energy will be g mass of earth, mass of the object, divided by the distance between them, which is re, will be equal to final kinetic energy plus the potential energy. Potential energy will be minus g mass of earth, mass of the object, divided by r maximum. So by energy conservation we get this equation. Now we want that in order to calculate escape speed, we need to find out the velocity at which the object it goes away from the earth to an infinite distance. So it means that initial velocity will be escape velocity when the distance traveled by it is infinite. If it goes to the infinite distance, it means that it has escaped the earth gravitational pull, and therefore we say that that velocity will be escape velocity. So in this equation, 1 upon 2 mv escape squared minus g capital MEM upon RE will be equal to 0 plus 0, because now the maximum distance will be 0. Therefore from here we can find out V escape. So escape speed will be, now small m can cancel with small m, so escape speed will be 2g mass of earth divided by the radius of earth. So this is the minimum speed an object needs to escape the gravitational pull of earth. Now here we need to understand that V escape, it does not depend upon, it is independent of small m. It does not depend upon small m. So whatever is the mass of the object, it is independent of it. If it is, okay, I've got this root. So if it is greater than this velocity, it will escape the pull of earth. So now let's try to analyze this relation. Now when Vi is equal to V escape, then let's try to find out what is the initial velocity, initial energy again. Initial energy we know is Ki plus Ui, and it was equal to 1 upon 2 mvi squared minus g MEM upon Re. So now when it is escape speed, and we know that escape speed is given by 2g m upon Re under root. So it will be 1 upon 2 small m 2g me upon Re minus g MEM upon Re. So it turns out to be 0. So initial energy will be equal to 0. Also final energy we know is Kf plus Uf, so it will be 0 minus G capital MEM upon Re upon R maximum will also be 0, as R maximum is infinite. Here it should be smaller, as it is infinite, so final energy will also be 0. Now if the initial velocity is greater than the escape velocity, it means that you will have some initial energy which will not be equal to 0, and therefore the final energy will be something plus 0, because potential energy will be 0, because potential energy is equal to G capital MEM upon R maximum, and so If it is an infinite distance, it will be 0. So it means it will have some kinetic energy which will not be equal to 0. So it will be mvf squared plus 0. So it means that if the velocity is greater than the escape velocity, the object will escape the surface of Earth, and it will be moving with some velocity at an infinite distance. It will not come to rest, but it will be moving with some velocity. Okay, let me just explain you about the significance of escape velocity on the atoms. Now, average speed of hydrogen and helium atoms, their average velocity is very high. And therefore, because of this very high velocity, hydrogen and helium, they escape Earth atmosphere. And therefore, hydrogen and helium are not present on the atmosphere of Earth, in the atmosphere of Earth. Whereas in Jupiter, because Jupiter is the biggest planet, and in order to escape Jupiter, hydrogen and helium doesn't have much speed to give them a higher kinetic energy, initial kinetic energy. Therefore, they cannot escape the atmosphere of Jupiter. Therefore, hydrogen and helium, they are present in its atmosphere. Okay, that's all.